The Foundations of Geometry by David Hilbert. Chapter 2. The Compatibility and Mutual Independence of the Axioms. Section 10. Independence of the Axioms of Parallels, Non-Euclidean Geometry. Having shown that the axioms of the above system are not contradictory to one another, it is of interest to investigate the question of their mutual independence. In fact, it may seem to be shown that none of them can be deduced from the remaining ones by any logical process of reasoning. First of all, so far as the particular axioms of groups 1, 2, and 4 are concerned, it is easy to show that the axioms of these groups are each independent of the other of the same group. According to our presentation, the axioms of groups 1 and 2 form the basis of the remaining axioms. It is sufficient, therefore, to show that each of the groups 2, 4, and 5 is independent of the others. The first statement of the axiom of parallels can be demonstrated by the aid of the axioms of groups 1, 2, and 4. In order to do this, join the given point A with an arbitrary point B of the straight line A. Let C be any other point of the given straight line. At the point A on AB, construct the angle ABC so that it shall lie in the same plane alpha as the point C, but upon the opposite side of AB from it. The straight line thus obtained through A does not meet the given straight line A, for if it should cut it, say, in the point D, and if we suppose B to be situated between C and D, we should then find on point A point D prime so situated that B would lie between D and D prime, and moreover so that we should have AD congruent to BD prime. Because of the congruence of the two triangles ABD and BAD prime, we have also the angle BAD congruent to the angle BAD prime, and since the angles ABD prime and ABD are supplementary, it follows from Theorem 12 that the angles BAD and BAD prime are also supplementary. This, however, cannot be true, as by Theorem 1, two straight lines cannot intersect in more than one point, which would be the case if BAD and BAD prime were supplementary. The second statement of the axiom of parallels is independent of all the other axioms. This may be most easily shown in the following well-known manner. As the individual elements of a geometry of space, select the points, straight lines, and planes of the ordinary geometry as constructed in Section 9, and regard these elements as restricted in extent to the interior of a fixed sphere. Then define the congruences of this geometry by aid of such linear transformations of the ordinary geometry as transform the fixed sphere into itself. By suitable conventions, we can make this non-Euclidean geometry obey all the axioms of our system except the axiom of Euclid, Group 3. Since the possibility of ordinary geometry has already been established, that of the non-Euclidean geometry is now an immediate consequence of the above considerations. The Foundations of Geometry by David Hilbert. The material contained in the following translation was given in substance by Professor Hilbert as a course of lectures on Euclidean geometry at the University of Göttingen during the winter semester of 1898 and 1899. It was translated by E. J. Townsend, Ph.D., University of Illinois. The text was downloaded from Project Gutenberg with the following notice. This ebook is for the use of anyone, anywhere in the United States and most other parts of the world at no cost and with almost no restrictions whatsoever. Read by Jim Wrenholt. Programming and illustrations by Jim Wrenholt. 2019. Portrait of David Hilbert by Reida Wrenholt. Thank you for listening.